finished with my shopping at Target, I push my shopping cart to the checkout stations. I look left and right, trying to find the fastest line. I see line 1, a person with 15 items, a full shopping cart. Then I see line 2, 3 people, each with 3 items, no shopping cart at all, just carrying the items in their hands. Which line should I choose? I, as many other people, would choose a line with fewer items, so that would be line 2. However, we are all wrong. Now, let's take a look at the numbers drawn from statistics. For every 1 item added to a checkout line, it's only 2.8 extra seconds to scan. But for every person added to a checkout line, it's a whopping 48 extra seconds for payment processing. But wait, there's more. The cashier has more words to say. Hello, did you find everything you need? Thank you, and have a nice day. And on top of that, the new, more secure chip cards take up a really long time. Wait. Don't remove your card. Wait. Beep, beep. So, doing the math, it's only 90 seconds for line 1, but a whopping 169 seconds for line 2. Yeah, we can see the difference. So as long as our society puts on a statistical lenses when we view our daily problems, we gain a better sense of how to tackle those issues. Now that we've had a quick little introduction to the power of statistics, let's play a quick little game as to see who is the most strategic, or should I say, strategic. Anyways, I'll need a volunteer from the audience, so who would like to come up and help me out? Yes, young lady, would you mind coming up on stage? And so this game is called the Greed Game. And from the name alone, you may be able to tell the strategy behind the game already. And I encourage you to be thinking about that strategy as our volunteer walks up on stage. So what is your name?
I'm Danny Castle.
Danny, nice to meet you. I'm Andy. Thanks for volunteering. If you could just hold my calculator while I explain the rules of the game really quickly. All right, so as I said, this game is called the Greed Game. And in the Greed Game, you'll each start off with 5 points, and when we start, you'll be raising your hands. And then Danny here will simulate the roll of a die by using a random integer generator on the calculator. So if we turn the power on, when I say next number, if you could just press enter and call that number, and I'll tell the audience what that number is, that would be great. So when I say next number, that's what you'll do. So Danny here will generate the random number, and then if the number is any number except for 1, so if it's a 2, 3, 4, 5, or 6, you'll add that number to the current points you have. So if it's a 2, you'll add 2 points. If it's a 3, you'll add 3 points, and so on. But if the number is a 1, you will lose all the points you have in the round. So the goal is try to get as many points as possible without losing your points. Moreover, at any time, you can take the number of points you currently have by putting down your hand. Right? If you put your hand down, take the number of points you have, but after you put your hand down, you can't put it back up. If you put it down, you keep the points you have regardless of what Danny here rolls afterwards. The round will be over when either everyone in the audience puts their hands down or when Danny here rolls a 1. So, without any more stalling, let us begin. Could we all get our hands up? And we start off with 5 points. Would anyone like to take their 5 points right now before we start rolling? Anyone want to take their 5 points? All right, a couple of individuals over there. All right, then. Danny, if we get our first number, what may that be? Press enter. Oh, I think if you could help out a little here. If we could get our first number, what may that be? Just press enter. Here. It is a 4, right? So we're currently at 9 points. Anyone want to take their 9 points and put their hands down? All right, if we could get our second number, just press enter one more time. It is another 4, so we are at 13 points. Anyone want to take 13 points? All right, next number. What is it? It is a 1. So, unfortunately, for those of you with hands up, you lost all the points in this round. But for those of you who put your hands down in time, you keep the number of points you had when you put your hand down. And I know that round was sort of short, so we'll play another round. So if we could get our hands all back up, starting with 5 points again. This time, if you have your hands up when Danny rolls a 1, you still keep the points you had in round 1. So the rounds are independent of each other, right? Anyone want to take their 5 points this time before we start rolling? All right. Danny, if we could get our first number. What is it? It is a 1. Oh. Well, congratulations to those who put your hands down, because strategy pays off sometimes. But for those of you who had your hands still up, unfortunately you lost your points, but we'll give you another chance. And let's play our third and final round. So make your strategic guesses this time and put your hands back up, starting with 5 points. Keep track of your total points, sum of all your points. Anyone want to take their 5 points this time? All right. First number, Danny, please. It's a 6, so we are at 11 points. Anyone want to take their 11 points? All right, second number? 5, so we are at 16 points. Anyone want to take 16 points? All right, next number? It's a 4, so we are at 20 points. 20 points, anyone want to take 20 points? All right, next number? 6. We are at 26 points. 26 points. Anyone want to take 26 points? All right. Next number. 5. We are at 31 points. 31 points. Still many brave souls out there. All right. Next roll. 6. We are at 37 points. Anyone want to take 37 points? All right. Next roll. 5, we are at 42 points. 42 points. Anyone want to take 42 points? All right, still have some people going here. All right, next roll. 5, we are at 47 points. All right, 47 points. All right, still several brave souls here. All right, next roll. 2, we are at 49 points. All right, still, I think 4 more people here. Oh, a couple more here. All right, next roll. 4, we are at 53 points. We have surpassed the 50-point mark. Anyone want to take 53 points? All right. If we get the next roll. 1. So I'm sorry. For those of you with your hands up, you lost the jackpot here. But for those of you who put your hands down, as usual, you keep the points you had when you put your hands down. So I think 3 rounds, we can conclude our game here. Thank you, Danny, for volunteering. I could get my calculator back. But we're not quite done yet. So many of us want to be CEOs in our future company, or we are a CEO already. Or we want to be CTOs or CFOs or chief something officers. And today I'm here to give out some new titles to noteworthy individuals who deserve those titles. So starting with the first one. By a show of hands, how many of you had over 20 points in this game? Total, 20 points. All right, many of you. How about over 30 points? All right, over 30 points. How about over 35 points? All right, over 40 points, anyone? All right, still over 40 points. How about over 42 points? 44 points? How about 45? How many of you had over 45 points total? All right, so we have 3 individuals here. If you could shout out how many points you had?
47.
47. How about you, lady in the back? 56 points. And so I want 2 more hands here. How many points? 49 points. How about in the back? 53 points. So congratulations. Oh, do we have one more here? How many? 57 points. So we have 5 winners here. And for these individuals, I would like to call you the new CSOs, or Chief Strategic Officers of the 2016 TEDxYouth Conference. So congratulations. Thank you. And now for those who lost all your points in any of the round, since this is the greed game, I'd like to call you the CGOs, or the Chief Greedy Officers of the 2016 TEDxYouth at Conejo Conference. So for our new CSOs and CGOs, let's give a round of applause. Now, for you CGOs out there, you are determined, you're perseverant, you're courageous, and those are all good character traits. Today, you came up a little short, but we live to learn, as the saying goes. So as long as you have good statistical strategy or statistical lenses, we'll be able to do better next time. So let me share that strategy with you, the strategy of the greed game. So on the screen here, you will see a probability distribution with the different roll values, 1 through 6, and the respective probabilities. Let n equal your current points, and you can express each of the roll values as a mathematical expression. Now, when we calculate expected value after the roll, which is simply the mean, we simply multiply all the probabilities and their roll values and add them all up. So we get the expression 5, 6n plus 10/3, expected value. Now, the strategy of the greed game is to have more points after your roll than before your roll. So we can set up an inequality here with 5, 6n plus 10/3 is greater than n, and we use algebra to solve that n is less than 20. Now, what that means is that as long as you have fewer than 20 points, you are more likely to gain points by rolling than you are by putting your hands down. So that's a strategy, to simply put your hands down once you have at least 20 points. Now, this strategy will be true always, as long as we play the game an infinite number of times. But, of course, we don't play the game an infinite number of times. And this strategy isn't necessarily true in the short run. As you saw, one of the rounds got up to 53 points. So that's the beauty of statistics in the greed game. It's about luck, it's about randomness, it's about chance, it's about uncertainty. And that's the beauty of statistics at large. Now that we've played a quick little game as to probability, luck, and statistics, let's take a look into an actual case in the real world released by the US National Library of Medicine. So the example I'm about to show deals with what's called a lurking variable, which is a variable whose effects on the response cannot be clearly distinguished from the explanatory variable, which in this case is 2 treatments of kidney stones, right? They're treatments in removing kidney stones, open surgery and small puncture. As we can see here on the screen, small puncture appears to be more successful. It's 83% as opposed to 78%. So we're going to go with small puncture if we're going to get our kidney stones removed. But let's take a look at this data one step further. If we break it apart by the size of the kidney stone, small versus large stone, we'll see open surgery is in fact more effective for both sizes of stones, as you can see here. This is an example of what's called Simpsons Paradox, which is when the direction of an association can be completely reversed when we expose the lurking variable, which in this case is the size of the kidney stone. Now, the reason behind Simpsons Paradox is because, first, large stones are inherently more difficult to treat, lower success rates, and also open surgery is assigned many more instances of the large stone. So on the whole, it appears that open surgery is less effective, even though it is more effective when considering the size of the stones, it's more effective than small puncture. So when we're getting our kidney stones removed, if we're statistically illiterate, we may have the doctors use small puncture. But if we are statistically literate, then we'll make the correct decision of using open surgery. Now, we've just taken a look at data analysis. And let's talk about how we get these data. We get these data through observational studies, experiments, and surveys. Let's talk about surveys. Many of us know surveys as a type of study where we ask a group of people, called a sample, a question of interest. For my AP Statistics project, this question of interest was, would you like to be an organ donor? Because our organ transplant waiting list in America is growing by the minute. So I was curious as to see how many people support donating their organs. Now, in this study, I examined what's called wording bias, which is the phenomenon if we apply a wording bias, which is turning the question into a certain wording, it could skew the results and not give us a clear image of what the actual population believes. So I asked 3 forms of the question. First, would you like to be an organ donor? Neutral question. Second, each organ donor can save up to 8 lives. Would you want to be an organ donor? Skew towards a yes response. And third, being an organ donor can cause the body to be taken away from the family right after death during a period of mourning. Would you like to be an organ donor? Skew towards, of course, a no response. And so I conducted my survey and gathered my results, and in 3 pie charts or circle graphs you see on the screen, you'll see those results. Now, my question for you, the audience members, is which one corresponds to the neutral question? So I'll give you a couple of moments to look at the graph, and then I'll ask you by a show of hands which one you think corresponds to the neutral question. So by a show of hands, how many of you think figure 1 corresponds to the neutral question? All right, many of you. How about figure 2? Figure 2, some people over there. How about figure 3? All right. The correct answer is figure 1. Congratulations to those who got it right. And now we can tell that figure 1 is the correct answer because it has some moderate percentages. It has the percentages in the middle as sort of like the average of what the other two graphs show. But the thing to take away from this example is all 3 graphs represent essentially the same question: would you want to be an organ donor? But the fact that wording bias was applied causes us to have completely different results. And if we don't put on sharp statistical lenses as to see which one is the neutral question, if we don't put on lenses to analyze a bias, we may come up with completely incorrect results, concluding that majority supports organ donation or the converse of that statement. So, at least for me, this project was rather low stakes, just an example in an in-class project. But in the real world, statistics can be a lot more high stakes. As in the kidney stone example, a person may suffer unnecessary pain due to statistical illiteracy. Data is everywhere, in grocery stores, in hospitals, in economics, in our daily lives. The discovery of water on Mars was made using statistics. The increase in average household income is also measured using statistics. And the decision to sell diapers next to beer was made using statistics. Of course, fathers who had children that needed diapers needed to drink beer to comfort themselves. And all data are analyzed using statistics. But not all analyses are valid. Only those that use proper statistical lenses are valid. Similar to what Professor Arthur Benjamin, my favorite TED speaker, had once said, statistics isn't just about solving for X, it's about finding out why. W-H-Y. It's about uncovering the lurking variables, analyzing the bias in surveys, and discovering just when to stop rolling that die. Whether it's saving a life in medicine, or saving a couple extra minutes at the grocery store, or being the next CSO, statistics matters, and our decisions need to be statistically literate. And once again, I echo Professor Benjamin, our knowledge needs to lie 3 standard deviations above the mean, and I mean it. Thank you very much.